Yeah. Okay. And you are there. So.
So hello back. Hello again. So, okay, let's put this here.
Yeah. Okay.
Okay. So let's continue. So let's revise the software testing activities. So the software testing activities, we have software design, we have test automation and test execution and test evaluation. So the software design, in which we focus on input and output. So we have the input and the expected output. And we have the test automation, which the goal is to also address things related to the environment, how to set the environment in the correct, like on the state that we want to test from, and how to return it to the stable state. Then we have test execution, which generate output from the input based on the test cases that we created. Then we have the test evaluation, which is taking the output and expected output, it analyze it, and based on that, it assigns something called verdict, which is pass, fail, or inconclusive. So it can be pass. Pass means that, okay, I'm expecting 1, I get 1. I'm expecting 0, I get 0. Fail means I expect 1, I get 2. I expect 2, I get 5. So this is fail. What about inconclusive? Why we have inconclusive cases? Anyone can think of something that can result in inconclusive thing? What do you think? So inconclusive, that this means that I'm not able to tell if the test pass or fail. This means that maybe the test did not finish executing or just crash without producing output. So it's a failure if it crashed, but if it's not failure if it did not finish execution. Because sometimes the execution depends on other factors, such as in distributed systems, that we don't know what happened. Your query just lost somewhere, and we don't know if the unit that you're testing is wrong or something happened in the distributed system. So you can't tell, or there's cases. So for example, there's cases where you can't test. So testing for next prime number, big prime number. So as you know, there is a machine that is running all the time in the world that produced next prime number. So the last prime number produced, I think it was in 2016. Now the one that's expected next, I think in 2019. You need 2 years just to produce the output. You don't know what's the output. So why we need these prime numbers? Because these prime numbers can be used in security, can be used in many applications. So these are huge prime numbers. And why those are important? Because they cannot be factored. So those numbers are important in like for many reasons. Yeah. Yes. You have question? You have question? Okay. So something like this also cannot, like the result will not. It's not easy to tell that it's. You don't know expected result in this case. Yeah. So what's design criterion? We already have an idea what's a design criterion. So design criterion, a collection of rules and a process that define test requirements in order to achieve a certain measure of testing thoroughness, such as when we talked about statement coverage. So statement coverage is a criterion. Test requirement specific things that must be satisfied or covered during testing. So I say, okay, I need to execute statement 1 and statement 2. This is requirements. So my requirement is to satisfy, to execute those 2 statements. So based on the requirements should provide me with certain certainty about the criterion. Like I can say, if I satisfy these requirements, I have 100% satisfaction of the criterion. So here, for example, cover all possible outputs, cover every statement, while in test requirements, the list of statements that need to be executed, the list of paths that need to be covered, and as we mentioned, some requirements may be infeasible. You cannot satisfy. In industry, you can't have 100% statement coverage, the one that I explained here. Anyone knows why? Why I can't have 100% statement coverage? So remember that this is done in an automated way. So a program will tell you the number of statements, and a program will tell you that the number of statements executed. In many cases, you have dead code. You have places where the programmer did not link yet to the, which is what's called dead code, link to the actual execution control, or forget about it, or so these still counted as statement that need to be executed and will not be executed ever, because the control will not reach to them. Or you have a condition that will never be satisfied. Like, okay, temperature goes, if temperature goes below like -100 in Iceland, then do something. Okay, it will never be below -100, so this will never be executed. So this is, it can be path, or it can be, because it's not good code, good quality, but do you consider these? I mean, depends. Is it something that you should check for some reason? Of course, if it does not have any link to the reality, then of course it's just redundant, does not need to be there. Yeah. But this is also one of the things that you want to discover. I mean, these are faults also in the program. When you have bad code, then also these things that you have to alert the programmer about. So why this code is not executed? Is it dead code? Is it something that need to be removed? Is it something? So we talked about test criteria and test requirement. So test requirement address the what aspect, what need to be tested. It includes normal and error conditions, cover business rules, functionality, non-functional standards, functional, non-functional. I hope all of you knows now what's functional, non-functional things. Performance, non-functional or non-functional? Okay, non-functional, most people says. Depends how you can define it, but I mean non-functional. Cover business rules, functionality, non-functionality, do not have any case-specific data values, and so on. So do not have case-specific data values. This is important. I mean, so it's generic case. It's not specific case. When you have 1111, this is, or 11 as input, this is not test requirements. So testing for x equal 11 is not test requirement. This is a test case. Test requirement, testing that statement 1 executed. See the difference? So test requirement, if we take a case of inserting record into a table, so test requirements can be validate that you can insert an entry, validate that the insertion fails if entry already present, which are all these functional requirements. Validate that insertion fails if table already full. Validate that you can insert an entry to an empty table. Anyone can give me test case for these test requirements? So for first one, validate that you can insert an entry. Insert Marta. Okay, so something like this, like if it have names, then something like this will be a specific case. Okay, so we have, what's the output of the test? So we have, this is a phase in test activities, test design. What's the output of test design? So when I design test, I set test criteria and test requirements. Based on that, I create test specifications and test cases. Okay, so the input of the test design is requirements and the criterion. And the output will be specifications and test cases, which is actual thing that we need to execute. So the specifications describe how to construct test cases, and test cases is actual, like is instantiation of test specification. Usually simple pair, input, expected output. The extended version, input, expected output, prefix, postfix. Example of test cases for if we have a program that just calculate the square root, then it can be, this is just arbitrary for examples, 0, 0, 25, 5, which is the square root, 46, whatever, 100.5, whatever. I mean, these are test cases that we test for. This is also something that we need to define. How to, like, if, as we know, like when you get the square root, this number can goes like until infinity sometimes, right? So we need to define how to round it, because the program itself, if you automate this, will not know that it will round it to this value. It will tell you fail. I expect this, and I get this, and this is not the same. It's not equal. This fail. So you have to define rules for how to evaluate the results. I mean, every step need. It looks simple, but it needs more advanced techniques and more thinking and more process to it in order to be able to achieve your goal. So we have test case values, expected results, we already covered them, prefix values, postfix values. So any input necessary to put the software into appropriate state, and any input that needs to be sent after the test cases values. There is two types of postfix: verification values and exit values. So the verification value is necessary to see the results in the test case values, such as truncating, like at the end, say, okay, I round this. This can be part of the postfix condition. And exit commands, things that put the system on the stable state. Why we need this? Because not all systems are stateless. I think this is, stateless systems. So we have stateless and state-oriented systems. What's the difference between stateless and state-oriented systems? In stateless systems, I don't need to memorize the state of the program. So I give input, I get always output. A compiler, for example, if you give it a program, it will produce an output. It always produces the same output for the same program. That does not matter if this is in the morning or at night, or many programs work like this. Calculator works like this, to always give you the same output for the same input. But a transaction system such as ATM transaction system can have different outputs based on the previous operation that happened. A traffic light system takes same input all the time, same signal all the time. but it changes state. And depends on the state that it's in, it can produce different outputs. So if I give signal and I'm in green, I go to yellow. If I'm get the signal, I go to red. Same signal, I go to, I don't know. So it's based on the state, not only on the input, it's also based on the state. So the output also depends on the state. So this is on state-oriented systems. So in order to test the system, you need to put the system on the reset, like on the same state that you started from, because else you don't know the expected output. So concrete example of, and I want you to help me solving this. So we have this program. Our test criterion is the test must cover all possible valid outputs. I want to have test requirements, test specifications, and test cases. So the program, simple program, course result, take midterm and final. And the total will be midterm plus final. If the total is greater than or equal 5, then pass. And if it's less than 5, then it fail and end. So very simple program. So what's the criterion that I have? What's the criterion? It's written in front of you. Check both pass and fail. So what's the specifications? Or let's say what's the test requirements first? So print pass, print pass, or fail, which is execute line 4, execute line 7. What's the test specification? It's how. So how to execute this and how to execute this in generic case. So how to execute, how to print pass or execute line 4 and how to execute line 7. So if midterm plus final greater than 5 or equal 5, then it will pass. And if it's less than 5, it will fail. Those are specifications. And what are test cases? Test cases is the easiest one. Everyone should say that test case. Example. Okay, 4 and 6, which is 4 and 6. 4 and 6 will work, but it will be wrong value, right? It will be 10. Yeah, so it will print pass like in this case, but it will be, yeah, so we did not check for this. This is a fault, right? Yeah. 6 and 4 is good, but I mean, it's not fail because it's 10. But 11 will be a problem. So, but still he passed if we get 11. Anyway, so midterm 3, final 4, output pass. This is an example of a case of pass, and midterm 1, final 2, output fail. This is another test cases. So those two test cases should satisfy the requirement or not. So if I execute one of these, I have 50% coverage of this requirement. If I execute both of them, I will have 100% coverage of the criteria. Test oracle, okay. So test oracle is the mechanism that verifies the correctness of program output. The outcome can take different values. It can like value produced by the program, state change, as we explained before, a sequence of values which can be interpreted by the program or by the postfix maybe. And the test oracle can generate expected results, and we use it to compare with the actual results in order to say pass or fail. Finding the right oracle can be very difficult because it has two other problems called controllability and observability, which is part of the automation process. How to control the program in order to generate this kind of output, the oracle, and how to observe it, where from to observe it, which state to observe in order to be able to see the output. This looks easy, but both problems from theoretical point of view, they're undecidable. So test automation, should I cover test automation?
Yes, please.
I can cover it. Like this is not like it can be passed smooth. Okay, so test automation is how to use to take these test cases that you created and you put them in test suites and make them as a script to be executed. So control execution, we use usually software to do this, to automate this process, to control the execution of tests, compare the actual result, and set up the preconditions and post conditions. The advantage of test automation is to reduce cost, to reduce human errors, to reduce the variance in test quality and different, and to reduce also the cost of regression testing. Anyone knows what regression testing? So once you test your program, if you do any changes on your program, you need to test it again, right? So someone find a bug, or someone add new requirements. I implemented new thing. I have to test the program again. This is called regression testing. In regression testing, you have to repeat all the tests again and test maybe extra things. So instead of repeating everything, if you have a program that automates this, then you can just run it and it will test what already previously done. So the software testability is the degree to which the system or component facilitate the establishment of test criteria and evaluation of the performance of tests to determine whether those test criteria has been met. So how hard is to find faults in the software, which is undecidable also. It's based on two things, which is how to provide the test values to the software, which is controllability, and how to observe the result, which is observability. And the definition of software observability and software controllability. So controllability is difficult because there's lots of things. Like if it's easy to control a system that only takes input from the keyboard, but when a system depends on other factors such as sensors, distributed software, this can be much harder. So you have to think about testing a system, not testing just unit testing. So unit testing is sometimes easy, but when you integrate things together, it becomes much more harder because the dependencies increase. So we have test case, test suite, and executable test script. All of you know what's this. Input, output, test case, set of input, output, test suite, and executable test script is a script that executes the test suite. Okay. Test automation frameworks. There is lots of frameworks that enable us to do this automation process that we mentioned before. One of them is, there is here like a link for the differences between these. One of the main ones that you know and you will hear about in different places is called JUnit for Java unit testing. There is also NUnit for C# if you're C# people or Microsoft. So there is lots of unit testing frameworks, and these facilitate the automation of test creation and test automation. So it automates tests, it generates what we call test drivers. So a test driver is the program that will run the test cases, and it allows us to do assertions, which is test case, which is testing it for pass and fail, and have common test data, and have test runners that allow us to run the test. I mean, it facilitates the way that we deal with the test in order to be able to do the test. And it have IDE that can be part of Eclipse that can be very easy to use. I recommend that you look at this and try to see it. There's lots of YouTube videos that talk about how to use JUnit and testing. I will explain just briefly what you have here. So we have set of assertions such as assert true, assert false, and fail. So if I write assert true, which is a programming like construct, it will, anything inside this will be either true or false. And if it's true, the case will pass. If false, the case will fail. So it's mainly providing your test cases, the input and expected output. This is what it does. But you can run the program, and instead of running it by hand, you can write it as script. That's the point. And you can have fixtures such as at before and at after. What are these things? At before and at after, which is the prefix and postfix, the one that we were talking about before. Putting the system in the state and returning to the original state, or providing the values to put it on the state where we start testing from, the at before and at after. So as an example, so I recommend, if you want to use JUnit, use it with Maven as Maven project. The only thing you need to do is to create Maven project rather than normal project. That's the only thing that you need to do. Why? Because it comes with the JUnit framework, and it does all the configurations that you need, the XML configurations that you need to link it. So simple JUnit, like if I want to test this, that add works fine, this will be the JUnit class that we will write it. So all what you need to do in Java, like on Eclipse, is to right click on this and say, okay, add new test, and it will create at least the first part for you, and you name this based on this. So calculator class at test means that this is a test for one of the functions of the class, which is the public void add, which is this one. So I put assert true, and I say 5 equal calc.add 2, 3. This means that this will create an object of calc and pass 2 and 3, and it will check if it equals to 5 or not. So it passes if it's correct, if it fails if it's not. That's all what it does. And
So were the test cases put in JUnit?
yes, you can put all your test cases on as part. So for each class, you can create test class, and you can have all the functions of them. You can have multiple functions for each method, because you may test different aspects for each method. And when you run, you can run single test case, or you can run the test suite, they call it. So you run everything, and it will tell you 50% pass or 30% pass, whatever. And it will tell you all statements, what passed, and you can check it. Yeah, I have tutorial for this. If you're interested, I can pass it to you, like that part of the course. We give tutorial that explain this, like in the lab usually. Yeah. Okay, so we explained this. So as summary for this lecture, the only way to make testing efficient as well as effective is to automate it as much as possible. Because if you don't automate it also, you have human errors, you have other factors that can affect the whole process. I recommend always also to use some of the virtualization techniques that allow you to set up the environment in the same way for all people. Like in the course, I recommend that they use something called Docker, which is creating some kind of virtual machines in order to always, when you test within the same environment. So you create this test environment, and it's the same for everyone else. And test frameworks provide very simple ways to automate our tests, such as JUnit. But it's not silver bullet, because like what test values to use. This is the problem, which is the core of test design. So test design is an art by itself, and that's why we teach test design in this university, because you need to learn the different techniques that can be used in test design. So yes, you can, using JUnit and these frameworks does not solve the problem, because at the end, you still need to do the test design. Learning, having C# or .NET framework is good, but you still need to learn how to program. If you don't know how to program, then you can't. Does not help to have C#. Okay, and that's all, I think. Yeah, okay. So thank you. If you have any questions, yeah, please feel free to ask.
Let's thank you. Do you have any quick questions for Muhammad for the lecture? You good? Okay. Thank you very much.
You're welcome. It was a pleasure being with you all. And as we mentioned also before, we at the CRIS Research Center always looking for motivated students. So if you have any ideas or you want to participate in any project that we are currently running, yeah, please feel free to contact me, contact Marta, or to contact any people, of the people that you saw in the first slide. Okay, thank you.
I will say, ég verð hérna í 10 mínútur í viðbót ef þið viljið tala við mig verkefnið. I was just thinking that we could stop the